Before we jump right into the demo, let's take a moment and recap the architecture. Well, in the past, we've had demonstrations with our VO-NOS spanning multiple states, including one demo with nodes simultaneously in Virginia, Colorado, and Florida. All nodes for this demonstration will be located at 210 Research Boulevard in Aberdeen, Maryland. Our two prototypes are parked in the parking lot, with the black trailer at near full mast and the tan trailer only at perhaps 1/4 mast, just to see the difference. With the console configured for a satellite map, we can first see the marker representing the headquarters node running the console software on my i7 Asus laptop. In terms of the VO-NOS demo architecture diagram, you can see this represented here, and in the physical real world, we're over here on the second floor. Our lab node is also on the second floor of the building. The camera is aimed out the window, and the RF sensor has a simple monopole antenna hanging from the blinds. The tan VO prototype trailer is out in the back of the parking lot here, and here it is in the architecture diagram and in the photo. And last but not least is our black prototype trailer in the back of the parking lot here, just a bit northwest of the tan trailer. And here it is in the architecture diagram in the photo. Well, this is a screenshot, and we'll go live in a minute. You can see the green lines depicting VO-NOS connectivity status. Now we'll go ahead and start the console and run through the operational demonstration. There are a few user prompts to set preferences for this session. First, do we want to immediately begin polling all sensor states? And as you can see, the icons are currently blue, meaning they have no state report on record. Once we start polling, you'll see the icon status reflected by the icon color. Yes, they're all green, as all 7 demo sensors are up and actively reporting. Second, do you want to send stale sensor notification alerts? For the demo here, the answer is yes. We're going to be demonstrating later how when the sensor goes down, the alert is reflected on the control status and the message alert is sent out. Third, begin logging. Similarly, we want to demonstrate that, so we'll say yes. Fourth, provides the operator the choice of whether or not to include the network connectivity status lines as an overlay between the console and the sensor nodes. Again, we'll select yes for the demo. As you can see, the network connectivity lines have appeared. They're all green. Yellow lines would indicate poor or no connectivity at the networking layer. So now we'll click on the RF icon for Outpost 1 and open up the primary sensor. I keep the volume low because it interferes with the recording of the audio for the demo. As you can see by the active spectrogram, the sensor is active and running. This particular RF sensor has an analog devices Pluto SDR with a little stub antenna that comes with the SDR and software application SDR Angel. As you can see, it's currently configured as a wideband FM demodulator. In its stock configuration, the Pluto SDR has the AD9363 with an FM tuning range from 325 MHz to 3.8 GHz, a sampling rate of up to 61.44 megasamples per second, and a 20 MHz instantaneous bandwidth. As you can see, the sampling rate goes up to 20 MHz. 2 MHz actually seems to be more than sufficient for receiving wideband FM. With some firmware configuration, we can get an RF tuning range of 70 MHz to 6 GHz and an instantaneous bandwidth of 56 MHz. As you can see, this tuning range enables us to receive commercial FM radio stations. The low-pass filter on the front end is currently 200 kHz, and that's also more than sufficient for broadcast FM. FM broadcast makes for a good basic demo, since there's FM broadcast signals handy to receive, and it's clear when the signal's being received and demodulated. All right, so we'll close out this RF sensor, and we'll go to the Mutex sensor, which is Outpost 8, the video sensor on the same platform. So this is Outpost 8. To conserve bandwidth, I leave these in playback mode, but I can provide a live view. You can see the live view loading here. It should come active in a second. All right, there it is, the live view of the 210 Research Boulevard parking lot. So, switching back to playback mode, you can see the stored events for each date on the calendar. These little blue lines down here are the events from yesterday. So let's see what happened last night. Is there anything interesting? Well, this appears to be the police doing a night patrol through the parking lot. Well, that's it for the tan trailer. Let's move on. Now we'll move over to the sensors on the black trailer. The black trailer has as its seminal sensor Outpost 2, the radiation sensor, and Mutex sensors Outpost 5, a video sensor, and Outpost 4, an RF sensor. First, we'll take a quick peek at the radiation sensor. This is a GQ GMC 320 Plus nuclear radiation detector, and the associated software application is the GQ GMC Data Viewer. This sensor detects beta, gamma, and X-rays in the energy range of 0.1 to 3 mega electron volts and does automatic data recording. In terms of counts per minute, typical background radiation is 60 counts per minute. Anything above 100 counts per minute warrants attention, and anything above 1,000 counts per minute is serious. So as you can see, we look pretty safe here where this sensor is sensing. Moving on to Outpost 5, the Mutex video sensor on this platform. Note that the mast is currently extended higher than the tan trailer for this demo, and so the mission package is higher as well. The video capability is otherwise very similar to that on Post 8. But it may be important to note that there are 3 outposts running the Sentinel software on a single i5 NUC in this mission package. And that brings us to Outpost 4, the RF sensor on this platform. Similar to Outpost 1 for a performance comparison, this is also configured as a broadcast FM receiver with a Pluto SDR and the SDR Angel. With the mission package so high, I can get more radio stations. This mission package has a little bit better antenna in it too. The other Outpost 1 RF sensor has a little stub antenna that came with the SDR. In this mission package, with the Outpost 4 RF sensor, I use a broadband TV antenna designed for VHF UHF from 50 MHz to about 1 GHz in bandwidth. The antenna performs pretty well in this configuration. Of course, as a TV antenna, it's designed for 75 ohm coaxial input, and our SDR has a 50 ohm SMA connector. And so we may lose perhaps 1.7 dB of signal due to the impedance mismatch, but it's not really a problem. Several local FM signals seem to come in pretty well. All right, so that's it for the black trailer. Now we'll move over to the node in the lab, where I'll demonstrate these sensors, and also I'll demonstrate how the VO-NOS reacts to an RF signal of interest triggered event, and how the VO-NOS reacts when a node has gone stale for a period of time. This third and final node has as the seminal sensor the video sensor on Outpost 3 and the Mutex RF sensor on Outpost 7. The Outpost 3 video sensor is a common ONN webcam attached to an i7 NUC in the lab, and the corresponding video application is a free download of ContaCam software. This actually works surprisingly well, but this camera is probably not as weatherproof as the Reolink solution. Here's the live video, and just like the other cameras, ContaCam can detect motion as well. Now to create the demonstration of the VO-NOS handling of a sensor going stale, I'll stop the Sentinel on Outpost 3. All right, so as you can see, the heartbeat stopped at 9:40. The timeout interval to mark sensors as stale is a configurable parameter on the console. It's currently set for about 4 minutes. While we wait for the sensor to time out, we'll go and work with the Outpost 7 RF sensor. Just to say a bit on this particular RF sensor, this RF sensor is using a different SDR with SDR Angel. The other RF sensors on Outpost 1 and Outpost 4 were Pluto SDRs. Here on Outpost 7, this is a hack RF, and this is a little cheaper but not quite as capable. The hack RF with no firmware update can tune from 1 MHz to 6 GHz, but the ADC is 8 bits compared to the 12-bit Pluto, which corresponds to a significant 24 dB difference in receive sensitivity, meaning the Pluto SDR can resolve much weaker signals without getting buried in quantization noise. Now, for the demonstration of a signal of interest event, I'll use the most convenient source I have, my pocket key fob for my truck. Like most US key fobs, this operates at 315 megahertz. So we're going to look for this as our signal of interest and trigger an event here. We'll first configure the duration of the event in terms of seconds before and after the trigger. I'll configure for only 1 second before and 1 second after. The system supports up to 10 seconds prior and post, but it consumes a lot of memory to record for long periods of time. To ensure this demonstration is clear, we'll up the gain on the low noise amp. Then we'll give it a test to make sure you can see the key fob signal. Okay, you can see the signal on the spectrograph and the waterfall chart. Now we'll set it to trigger a recording. When triggered, this record symbol turns red while the recording timer counts. There it is. Okay, we were able to trigger an event with my key fob, and you can see it's posting the recorded SDRIQ file named with date and timestamp. Now let's go back to the console. Yes, it's clear the signal was detected, and it's reported as an alert on Outpost 7 at the console. Outpost 3 still hasn't gone stale. While we continue to await the NOS timing out Outpost 3, we will clear out this Outpost 7 SOI alarm, and we'll demonstrate the playback from the SOI event. We're standing down the Outpost 7 Sentinel, as we don't want any more events distracting us while we're running the playback. To view the recorded SOI event, we'll invoke the file input and select the SDRIQ file with the record of the SOI event. Open, and we press play. The file player is configured to continuously loop. See the clock ticking through the playback? It continuously plays the same signal over and over at 3 seconds of data. We've already cleared the alert out in the Sentinel outpost. The console maintains the alert state until the console operator acknowledges the alert and clears it by toggling clear alarm. Now, opening up the log for today, you can see the SOI alarm on Outpost 7 reported and logged at 9:42. All right, I guess I must have triggered twice. Let's refresh the log, and yes, you can see the logged event for when Outpost 3 went stale. Let's check the email and see if the alerts were sent out and received. This is Outpost 7, so this was the RF signal detection that triggered my key fob, and it identifies the file name for the record for playback purposes. Here are the alerts for stale Outpost 3. Yes, you can see the console is now displaying this Outpost 3 as stale. My operations on remote sensors turned both off and they went stale. So let's put them back online one at a time. Okay, well that one should come back up in a second. That's back up. And now we'll go to this one, bring it back up. Give it a second to refresh. Should be less than 20 seconds. Okay. Just to summarize, we've demonstrated a network with multiple remotely accessed, unattended platforms with advantage sensor nodes on 25-foot masts. Each has a mission package with multiple sensors, including RF, radiation, and video sensors. We've demonstrated signal of interest detection, remote alerts, and logging, and we've demonstrated how the Vigilant Outpost console watches over the network of sensors to ensure the state of each is known at any point in time. Now we'd just like to say a quick word about the scalability of the VO-NOS architecture.
While our demo here today has only 3 platforms with a total of 7 sensors, scalability tests demonstrate that the VO-NOS, as implemented, is capable of well over 700 nodes. In fact, the testers ran out of virtual machines before we really reached the limitation of the VO-NOS in terms of scalability. That concludes our presentation on the demonstration of the Vigilant Outpost in August 2025 at 210 Research Blvd. For additional information on this or our other fine products, visit our YouTube channel or our website at www.vigilantoutpost.com.